Hey, welcome back. Last video I showed you the new Deckel debit grinder that I purchased, well, the used one. And I mentioned that I'm going to make a few wheel hubs for it, and well, here we are. I decided to make them myself because they are $105 a piece, and well, I can do that in my in my personal time. This is my hobby time when I make stuff like this. So let's have a look. Hey, welcome back. Today I have a little machining project for the Deckel debit grinder. I want more wheel hubs. This one I purchased from Front Singer. They cost about $100, and to be honest, it's a very okay price. I have a hard time making them for the same money, but also I'm a cheap ass. So I got some material. This is 42 chromoly S4. The S stands for sulfur. This is a variation of the 42 chromoly with sulfur added for a better machinability. It tends to break the chip a little bit better. This is hot rolled material. That's why we have the scale on the outside. Plus, it's a quenched and tempered material, so this already comes in at a higher strength and a little bit higher hardness. When I saw the original wheel hubs from Front Singer and also the original Deckel ones, I thought, oh, they're probably hardened because they are ground on the face here, on the OD here, and the taper is also ground. So I figured, well, I have to harden them or send them out to be hardened and rig up an ID grinding spindle to the taper, and a whole lot of steps to that sounded like an awful lot of work, but I checked the hardness and it came out at 22 HRC, which is not very hard. The 42 chromoly S4 comes in at 33 Rockwell C, just as it is. Hardness testing the original wheel hub that came with the grinder. Preloading. Dropping the weights, waiting for it to settle. Just by the way it settles, I already know that these are not very hard. And pushing lever, and we come out at 19 HRC. This matches what I checked before. In my previous tests, they came out to between 19 and 22 HRC. And here's a piece of the stock I'm using, 42 chromoly S4, sulfurized 42 chromoly. Let's see, find kind of top dead center, preloading. Everything in my life now has small diamond indentations. Waiting for it to settle and getting an actual reading, and we get 31 HRC. So the stock I'm using, the material, is already in the delivered state harder than the finished wheel hubs that came with the grinder. 33 HRC, or between 30 and 35 HRC, is machinable like any steel. It's just a little bit more taxing on the tooling, but machinability is great. So I think what they do is they take a high strength material, a QT material, and they just machine them and grind them. I don't think that there is a post-heat operation involved in making these. But that also meant for me, well, 22 Rockwell C, 33 from the steel I got. I can't machine them entirely on the lathe. I already did 2 test parts and they came out quite neat. And I just finished them entirely, precision bored the ID, and I think they will be perfectly fine. I made a test arbor. I just took a piece of 16 millimeter precision ground rod, clamped it in the spin fixture of the surface grinder, and I ground the taper similar to the taper of the debit grinder to check the fit of the hubs that I machine. These still lack the keyway, We'll do those with the slotting head on the milling machine. So this will be very non-spectacular. This will be just machining more of these. Now let's go. I'll use this piece here, and I will use a technique called, in German we call it the double piece. You machine two parts backed up to each other out of a piece of material, and that always allows you to grip on the other side, machine one side, flip it around, and that way you don't need extra grip stock in the chuck. So that's neat. I will basically cut this in half to create my double piece for making 4 more of these. I have not ran the lathe today, so let's do the daily ritual here. Wiping down all the exposed surfaces, just with a clean tissue, just from the dust that settled overnight on the machine. We don't have to push all the abrasive grit that settles. We don't have to push that around on the ways. Despite the machine having good and tight-fitting wipers, it's just not necessary to push the crap around on the ways. I just like to wipe down everything quickly. If it was a cold day, I would also let the spindle run for a few minutes, but it has been fairly warm. Let's say it that way. So the machine, of course, needs to be oiled. That's a daily thing. We don't do any machining before the machine is completely lubricated. So oil gun with 220 weight, ISO 220 way oil. And we have 3 circ fittings in front here, which lubricate the front boxway, the dovetail of the cross slide, and all the gear mechanism inside the apron. So we just go onto each of them, give a few pumps, and you hear the oil squeeze out in there. Just give it a few pumps. Over here is another one. And this one. Oil is the cheapest maintenance on a machine. Cleanliness and oil don't cost anything. Well, oil costs something and cleanliness takes a little bit of time. But machines are expensive, and spending a few minutes cleaning doesn't hurt. And there is one circ fitting on the back of the carriage that's lubricating the back boxway. And there's another circ fitting, that's here. This is lubricating the cross slide nut. Then the compound has 2 circ fittings. One lubricates the dovetails, and the lower one lubricates the compound nut and screw, of course. This takes a few minutes, and it's just like cleaning up on the end of the day. It gets embedded into your habits at one point. So we're dealing with hot rolled stock that's not exactly round. So what I like to do is I grab the hot rolled stock just in a 6 jaw. I will just turn a little bit of a diameter here so I can grab it on a freshly machined diameter before proceeding. 1200 RPM and 1 5mm feet per revolution. This is a CCMT insert. I'm just quickly getting rid of the hot rolled layer so I don't have to deal with all the rusty scale. This allows me now to deal with clean metal without any rusty scale on it. I will also clean the chuck quickly. Another thing that I will do is I will face both parts to the same overall length. That makes flipping and working against the chuck face as a stop quicker. Okay, I will rough all 4 of the parts down. Well, it's 2 parts, but it will end up 2 wheel hubs each part. So I will rough them down entirely with 0.5mm in diameter allowance, just so I can rough everything and not be concerned about any heat input. Well, this is not exactly cold. Now I can take this. I already turned the major diameter for both of the parts that will split out of this blank. Well, it's roughed with 0.5mm allowance, but I just need to flip it around and turn the same 20.5mm boss on the other end, and then all the roughing is basically done, apart from drilling a hole all the way through it. But I will also do the second one, because I already have the jaws that far apart. I wisened up and mounted the chip guard. Less hot blue chips in my face, which is quite nice. So roughed out the second one. I dropped the RPM partially down to 900 RPM to give this poor little insert a fighting chance. I think this is hot. Yeah, this. So back to the other part. He's wearing gloves on a machine. Yep. But I'm not wearing the gloves while running the machine, just holding a part. So part is pushed up all the way against the face of the jaws. that will give me hopefully enough rigidity to rough down the second side without much issue, despite holding on a 20mm shank compared to a 50mm diameter before. But I think it will be fine. If it lacks a little bit of rigidity, well, I will take a little bit lighter cuts. So dropping the speed down to 900. I will grab this out of the spindle and go back to the other one, butt it up against the face of the jaws again, gronk down on it and rough down the second side. Wait, why are drilling with the tailstock? Isn't drilling with the carriage better? In my opinion, it is indeed better most of the time, but I don't have a 10mm drill chuck set up in a quick change tool post holder. My standard chuck is a 0 to 7mm Albrecht chuck in a multi-fix holder. And to use a 10mm chuck or a 13mm chuck, I have to swap tooling around, and I'm not a big fan of that. So that's one of the rare times when I use the tailstock for drilling. I don't drill much with twist drills above 6mm, so this is a rare occurrence. Okay, and with that, both of the blanks are drilled all the way through. There is one more roughing step that I want to take. There is a large counterbore on this side of the wheel hubs that later will receive the puller thread, the M16x1 internal thread that you use to pull the hubs off the spindle taper of the grinder. Why didn't you run flood oil when roughing the material on the OD? Well, I didn't want to smoke bomb myself. Heavy roughing, you saw the blue chips, and cutting oil do not go well together in a manual application. In a CNC lathe with a high pressure pump, you can get away with roughing and cutting oil, or it's very feasible, but not on a manual machine with a limitation on throughput on the oil. This is getting very long-winded. I think I need to get your attention back with this short cat video. adding 2 grooves to show me the extent of the part. The material between those 2 grooves is waste material. In an ideal world, my blank that I used to machine those 2 wheel hubs would be just as long as I needed, plus the saw curve in the middle. But I just split the stock I had on hand in half. That's how I ended up. So after sawing it apart, I will have a little bit more material to face off. Well, that's still fine. Still less material lost than if I left like 5 millimeters on each of them to grab them in the spindle. Just using this 1 millimeter grooving tool to add these as a guide for me to know what's going on. This is all going quite nicely along. Now, since all the roughing is done, I can start finishing them one after another. I'm running at 1200 RPM and I'm feeding 0.12 millimeters per rev. Yeah, 19.99, the 1 micron on the back. That's due to temperature. Well, yeah. Now I want to cut the thread relief. I'm just going to use the DCMT insert for this. Plunge in and then traverse over 1 millimeter. That's the thread relief. Now I need a face relief here. For that I will put the tool 2 notches over. This would be a good time to make a cool face grooving or face relieving tool like Robin has. Plunge 0.5 millimeters into the face of the part, and then draw it out to my dimension that I have. That's the face relief. That's so grinding wheels that get put on here are clamped on a larger diameter and not accidentally clamped just on a very small diameter. This ensures a way better axial run out with a grinding wheel. You would also do this, for example, on a saw blade arbor. Next tool, I'm going to use this DCMT boring bar. You might remember this. I made this years and years ago. This is a carbide shanked boring bar. Going to touch off here on the face of the part. Drop down to the bottom of the bore. Then I'm going to move this way outwards. Cut my thread relief, back out and clear the tool. Just squeeze a little bit of cutting oil in there. There we go. That's the thread relief. Chamfering tool. Threading on the OD. Full profile insert, so these are really nice. You just thread until your major diameter is correct. The loud clack-clonk noise you hear is, by the way, the brake of the lathe's motor, so there is not something breaking apart. Yeah, I know that you can't thread away from the spindle out of the thread relief, but my muscle memory works the other way around, so... Yeah, now that the tool cut the OD of the thread. Yeah, perfect. That's the kind of fit I like for a thread. Not overly tight, but not loose and wobbly. I'm not even going to do a spring pass. For ID threading I have this funny 20mm shank, but very small threading boring bar, indexable threading tool, very nice tool. I'm cranking it all the way down to the floor of the hole for my 0 in C direction. I have to stop the spindle before I hit 0, so that's very easy. I'm going to run the spindle at the slowest speed possible, 60 RPM, because I'm a scared little bunny when it comes to threading against the shoulder on an ID. I can run the motor faster, second speed, for returning out of the bore. There's a myth that threading inserts do not work at low speeds, and that's a myth. So for checking the thread, I can either unwind the cross slide out, or I can take the tool out to get clearance. Oh, it doesn't, by the way, hurt to properly clean whatever you're using as a thread gauge, like dropping it in the ultrasonic, or at least blow it off if there is a single piece of dust on a thread gauge. And especially when you try to gauge parts in stainless, you will be in a world for hurt. So cleanliness is important. Looking good. Screws down all the way to the bottom. That's perfectly fine. Oh, and by the way, I did make a CAD drawing. And because, well, I haven't done an actual 2D drawing that's not derived from a 3D model in Fusion in quite some time. So I used LibreCAD, which is an open source 2D CAD package, to draw this. And it's quite enjoyable. Nobody in his right mind would do this to make money, but well, this was quite fun to draw up. And also, I started drawing out an extended wheel hub, making 4 of 2 for a friend, 2 for myself. These are to space the grinding wheel off of the spindle head, or the headstock of the grinder, for example, when you use a cutoff wheel to get more clearance to the back. So these are a little bit tricky from a design standpoint, because they have a captive nut that not only pulls the wheel hub onto the taper, but also self-ejects when you loosen the nut. But I'm still in the playing around phase with the design. All that's left is some deburring from thread turning. And the last step is Kratex application on all the surfaces, which is a abrasive loaded rubber, just to knock down all the remaining hairline burrs and just creating a overall pleasing finish. Putting down a piece of paper towel so I don't get all the abrasive grit into my cutting oil. I have I think a 5-micron filter in the oil line, but still everything that's not in the oil doesn't need to get filtered out. Filters cost money. That's a piece of Kratex super glued to a piece of 5 by 5 millimeter square aluminum, just to do inside. You can also jam something like this inside a bore, but you don't have much support, and this will very quickly fatigue break off. Half a wheel hub. Well, it's also lacking the washer and the nut, of course, but that's the business end. Before we open the chuck, we think through again if there is anything left in this operation that we want to machine. But I think that's everything. We have the thread, we have the precision diameter here, we have the face relief and the face. OD is finished. Thread, deburr, it's nice and rounded to the touch, so we're good. We're clamping on a finished surface now, so we make sure that the chuck jaws are clean. So there is no chip between the jaw and the finished surface we're going to grab the part on. Yes, compressed air in this application is not ideal. You will drive chips into the body of the chuck, into its inner workings, but I take the chuck apart regularly, what most people don't do, and clean it out completely and re-lubricate. Most people that yell at you for using compressed air in this application with, "Oh, you will destroy the chuck," they simply never clean their darn tooling. Don't yell at me. Moderate clamping pressure so we don't leave marks. That's where the 6th jaw is really shining. And now we do the same on this side. You don't need to see this. Second side will be done in a second. I added a deep groove in the center to know where to place the bandsaw blade when splitting them apart, but that's 2 wheel hubs still attached to each other, and off to the bandsaw we go. That's, by the way, a 60-second cut. And yeah, this blade is lacking a bunch of teeth. That's the ka-chonk, ka-chonk, ka-chonk noise that you hear. And there's the 2 wheel hub blanks. I did a little jump forward in time, and here are the almost finished wheel hubs with the keyways and the taper already bored. I made 6 of them in total compared to original one. And I'm quite happy how they came out. They look good. Well, they are wheel hubs. They are not the most complicated part in the world. I have to split this video in 2 parts because it's becoming longer than the extended cut of Lord of the Rings. And part 2 will have grinding the slotting tool, boring the taper, and also slotting the keyway. So yeah, thank you for watching this far. part 2 shouldn't take too long to edit and upload. Thank you all for watching, thanks for the support, and I'll be back.